2 years ago, analysts laughed at the idea that a humanoid robot could independently carry out tasks on a real production line. Today, one of the largest automotive lines in the world has been dismantled, and what's being assembled in its place isn't cars. And the very creator of this project has publicly stated that artificial intelligence could surpass the combined intelligence of humanity within 5 years. What exactly is happening at the factory in Fremont? And why does it change not only the robotics industry, but the global balance of technological power? Following the financial results for the second quarter of 2026, Elon Musk made statements that few expected to hear in such a format. The talk wasn't about profits or electric vehicle sales. The main subject was the Optimus robot, and the scale of what was announced went far beyond yet another corporate earnings report. Let's start with a fact that speaks volumes on its own. Tesla has dismantled the Model S and Model X production line at its factory in Fremont, a line that had been running for years. In its place, the company is now building its first ever dedicated assembly conveyor for humanoid robots. Production of the Optimus Gen 3 has officially begun. This is no longer a concept or a prototype. This is real production infrastructure. Musk clarified that the first production batches will launch in the third quarter of this year. However, he immediately cautioned that scaling up volumes will be slow and gradual. Tesla is not aiming to immediately produce hundreds of thousands of robots. At the initial stage, the priority is validating the line, identifying structural issues, assessing component reliability, and collecting data on how the robots perform under real-world conditions. The first robots off the Fremont conveyor will not go on sale. They will be deployed internally within the company as part of a program called Optimus Academy. The essence of the program is to create a controlled environment where robots carry out tasks, make mistakes, receive corrections, and continuously generate data for training Tesla's neural networks. And here lies a fundamental point that distinguishes Tesla's approach from most of its competitors. The company doesn't want Optimus to simply execute pre-programmed movements. The goal is to teach the robot to receive a new task, independently assess the situation, work out a logical sequence of actions, and carry out the work without engineers having to write separate code each time. According to Musk, no humanoid robot in the world today is capable of doing this at a general-purpose level. Most existing humanoids make an impression in carefully choreographed demonstrations, but behind the scenes there are pre-written scripts, detailed spatial maps, simulated data, and rigidly prescribed sequences of actions. Optimus is being designed with a fundamentally different logic: to enter an unfamiliar room, perceive objects through cameras, understand an instruction in natural language, and independently determine the order of actions. On the investor call, Ashok Elliswamy explained that Tesla is training Optimus using the same strategy the company developed for its full self-driving system. The inputs are pixels, the outputs are control signals. In the case of a car, cameras capture lane markings, pedestrians, and other vehicles, and the neural network decides how to steer and when to brake. With the robot, the principle is the same, but the task is an order of magnitude more complex. Optimus must not only recognize an object, but also determine how to pick it up, with how much force, and how to adjust its grip if the object starts to slip. To tackle this challenge, Tesla uses several sources of training data. The first is company employees who carry out tasks in front of the robots, teaching them through imitation. Specialist teams then create higher quality, high-resolution demonstrations to refine the datasets. The second source is video from the internet, primarily instructional content. The internet contains millions of examples of people cooking food, repairing equipment, working with tools, and fulfilling orders in warehouses. Musk has spoken on numerous occasions about his intention to train Optimus on videos from platforms such as YouTube. The logic here is sound. If a robot can watch an instructional video and, like a human, learn to carry out the action being demonstrated, the scalability of skills becomes enormous. It could master virtually any task simply by watching people do it. But it's important to understand that internet video doesn't automatically translate into robot skills. Tesla must develop systems that convert visual signals into precise physical movements. A person in a video picks up a glass, and it looks simple. For Optimus, this means precisely calculating the movements of the shoulder, elbow, wrist, and every finger. The data collected by Optimus Academy is intended to bridge exactly that gap. Another important principle is at work here. The experience of one robot becomes the property of the entire fleet. Data accumulated by a group of robots is processed and distributed across the whole fleet via software updates. Each Optimus learns not only from its own experience, it receives knowledge from all the others. Musk also mentioned the concept of a digital Optimus, a large-scale virtual agent that can exist without a physical body. Such an agent processes information, interacts with software systems, and develops cognitive capabilities in a virtual environment. These skills are then transferred to the physical robot. This allows Tesla to split the task into two independent tracks: intelligent scales in the digital space, whilst the physical body is validated under real-world conditions, more slowly but more reliably. Physical reliability is one of the key challenges. Optimus must operate for hours every day, repeat the same movements thousands of times, and maintain precision throughout. A joint that works flawlessly in a laboratory may not withstand months of continuous use on a production line. A hand capable of lifting a light object may not cope with tasks requiring high force and repeated impact loads. Musk stated that Optimus is being designed with dexterity comparable to, or even surpassing, the human hand. The goal is ambitious. The robot must be strong enough to lift heavy objects and delicate enough not to crush glass. At the same time, it must remain safe in close proximity to people. Musk was direct about this. A humanoid robot weighing around 70 kilograms carries real risks. If the control system loses stability or the robot loses power, it will fall exactly where it's working. The reliability of Optimus is not a matter of user experience. It is a fundamental safety requirement. But even if the software and mechanical challenges are resolved, Tesla will face a problem that receives far less attention. Optimus has virtually no ready-made supply chain. Musk described it as simultaneously the most promising and the most difficult product to scale in the company's history. The reason is straightforward. Most of the robot's components are entirely new. Compact actuators, high-precision mechanical hands, specialized control boards, none of this can simply be ordered from existing suppliers in industrial volumes. Tesla is compelled to design many components in-house and simultaneously persuade suppliers to invest in technologies that have never previously been manufactured at such a scale. Among the key partners, Musk highlighted Samsung and TSMC. Both companies are investing tens of billions of dollars in new semiconductor manufacturing capacity, and a portion of that capacity could be directed towards supporting Tesla's projects, including Optimus. This points to an important geopolitical reality. Tesla is not developing Optimus as an isolated robotics product. The company is embedding it within a unified AI computing ecosystem that serves autopilot, robotaxi, and all of Tesla's AI models. All of these systems depend on advanced chips, memory, and ultra-fast control systems. A shortage of AI chips will slow not only the training of Optimus, it will directly limit the number of robots Tesla is able to produce. Musk acknowledged that the company must overcome constraints in the areas of memory, logic chips, computing capacity, and advanced semiconductor packaging methods. A shortage of even a single critical component is capable of halting the entire production cycle. That is precisely why Micron has become Tesla's strategic partner for memory supply, despite the fact that prices for it remain, in Musk's words, exceptionally high. Tesla is competing for access to chips and memory not only with other robot manufacturers. Its rivals in this race are data center operators, cloud providers, smartphone manufacturers, and hundreds of other AI projects around the world. A shortage of one component can bring an entire production line to a standstill, even if everything else is ready. That is why Tesla is pushing for further vertical integration, designing control boards, power electronics, and specialized components in-house. The goal is not to abandon suppliers entirely, but to retain control over the most critical elements of the Optimus architecture. Optimus Gen 3 at the Fremont factory is the first real test of this entire strategy. Every component that is difficult to assemble, every production step that takes too long, every part that fails ahead of schedule, all of it will become data for the next generation. Optimus Gen 4 is planned for production at Tesla's factory in Austin. According to available information, it will incorporate components that are more amenable to mass production, along with a higher proportion of in-house designed parts. In mass production, a design that works is not the same as a design that can be produced at scale. If assembling one robot arm requires too many manual operations, and every unit needs dozens of hours of calibration after leaving the conveyor, high volumes at an accessible price point will be unachievable. Gen 4 must be not only smarter than Gen 3, it must be simpler to manufacture, fewer components, simplified joint assemblies, shorter wiring looms, greater integration of functions onto individual boards, and minimal manual labor on the line. Every minute saved on the conveyor becomes enormously significant when production volumes grow from a few hundred robots to tens of thousands. What is happening in Fremont right now is not simply the launch of a new product. It is the beginning of a production race that will determine who controls the market for physical labor in the age of artificial intelligence. And that market, by Musk's own estimates, could become the largest in the history of the technology industry. If you're interested in following this story as it unfolds, subscribe to the channel and give it a like. Every update on Optimus, we cover here first.